Hello, and welcome to your moment of Erlang. Today, we will be exploring how to load code by hand into the Erlang runtime system, specifically Elixir code. In order to do this, we'll need a few things. Erl, which is provided by any Erlang install, and starts the Erlang OTP, providing us with an E shell at which we can type Erlang commands. Elixir C, which is a part of any Elixir install, and gives us the ability to compile an Elixir file into a Beam file. And lastly, an example file. In my case, I've created one simple module called example, and it has one function that outputs the word hello to standard out. This utilizes the IO module from Elixir's standard library. Now, before we can call this function from within Erlang, we must first compile it into a format that the runtime can understand. And of course, the language of the Erlang runtime system is the Beam file. We can do this with Elixir C, passing it our example file, and outputting to the compiled directory. You can also compile an Erl file or an Erlang file in the same way. You'll just use ERLC or ERLC to compile it. Now that we've compiled our file, we can look in the compiled directory and see what we have. You'll see it has our module name.beam, but it has prefixed this Elixir word to it. This is to prevent namespace collisions whenever loading compiled Elixir files into the Erlang runtime system. You'll have to remember this whenever you want to call any Elixir module from within Erlang, and also anytime you compile any Elixir file, it will have this prefix. So with that in mind, let's start Erl and try and call our function. In order to access our function, the code server has to know about it. The code server is where Erlang will look for compiled object files for a module whenever we call them. It also provides us with the code module. Now, using the code module has an add path function that accepts one argument. In this case, we'll pass our compiled directory, meaning we want to add all of the Beam files within the compiled directory into the code server's path. Once we've done this, we can call our function. And it works. Well, it doesn't quite work. This is because we have not included the Elixir standard library in our running system yet. This is pretty easy though. We can do it in much the same way as we added our compiled directory before. This is where the compiled Beam files are for my Elixir install. Yours may be in a different place. The important thing to take away here is that the Erlang runtime system doesn't actually care where these files are. It just cares that it knows how to find a file for a specific module when you ask for it. And we will talk a bit more about this path in a moment, but for now we're just going to add it, and then we will call our output function again, and it works, which is super exciting. However, this is a little inconvenient. It would be better if we could load all of the modules and object files and Beam files or whatever whenever we start the system, so that we could just get to calling functions that we want to call. It turns out Erl has a path add flag for doing exactly this. We can pass our two flags to it, or our two directories to it as before, and start the system. And now we call our Elixir example module with the output function. It works with no additional commands required. Another benefit of using path add is it will accept the glob or splat operator from the shell. Glob or splat basically means any directory under lib, include these along with ebend. That's what it expands to in a shell. Let's have a look a little bit about what's in this lib directory from our Elixir install. You can see here there's IEX, logger, EEX, some of the normal stuff you would expect to find in Elixir install. Within each one of these directories, we'll look at Elixir, there are a few subfolders. We're mostly concerned about the ebend folder. And within here, you can see all of the compiled Beam files or object files for Elixir. That's why whenever we included this directory, then IO magically started working. Now, another benefit of having this glob operator here is that not only do we get the Elixir standard library, we can also pick up IEX and some other utilities. And in doing such, we can actually start IEX with our compiled code by hand. To do this, we need a few special flags. These flags almost warrant an episode on their own, and we'll probably talk about them a bit more in later episodes. But for now, we're just going to briefly describe them. The first one is no shell. No shell prevents Erl from starting an E shell and gives us access to standard in and standard out. The next one is user, which defines a module that we want to start up with and call start on specifically. In this case, we want to use Elixir, IEX, CLI, and I would encourage you to look at that module in the start function. It's pretty easy. It's pretty interesting what they've done there to make this work, and I would encourage you to poke around in it and play with it a little bit. The last one is extra. Extra passes additional arguments directly into the running system. In this case, we want no halt. No halt prevents the system from going down once it has started successfully, so it can just kind of, instead of stopping, stays in a loop, and we actually get a shell. And so here we have our interactive Elixir prompt, and our example module with the output function works. So the main takeaway I want from this to be that while Erlang and its runtime system is very opinionated about where it wants files to be whenever you are using releases or applications or upgrades or those types of things, Erlang is also quite malleable. And it is quite possible to do things the hard way if you want to. And sometimes along the way, you can learn something and hopefully have a little fun. Thank you for watching. This has been your Moment of Erlang.